Right, so welcome everybody. Last technical talk of the year. We were trying to do a person-to-person thing, but obviously we can't. So very grateful for Angus to join us and getting up at 7 a.m. in Germany. This is an open session, but if there's anybody online who's not a member of the Tunneling Society, it's very easy to do, especially if you're a member of Engineering New Zealand. But welcome to everybody. It's open. If you do join, of course, you've got discounts and reciprocal rights with other organisations, and it's worth doing. You get the Tunneling Journal and the Australasian version, the biannual magazine. So worth doing. A couple of quick things on the NZTS. Our annual general meeting, we'll have that in February. Try and coordinate that with a short course, and that'll be when the board elections will be held. I'll be standing down next year. We've got in behind Arnold Dix to be the ITA president, which will be elected in Copenhagen. And we're starting our preparations in a bit more earnestness for the ATS conference in 2023, which is in Auckland. The Area Night Working Group has kicked off, so that caused a bit of a flurry of excitement, certainly this time last year, but now that's starting to find its feet, which is good. And we'll try and have a board meeting before the end of this year. So back to Angus. He's the founder and chief of Maxwell Geosystems, XMOTS. We met up in Hong Kong many years ago on the SSDS arbitration. So thanks again, Angus, for taking the time to talk to us this evening, and I'll hand over to you. Thank you.
Thanks very much, Bill, and it's great to connect with everybody in New Zealand. I can't see the faces of people who are on the call, but I'm sure there's plenty of old friends who are there listening to this. What I'm going to give you really today is a bit of a journey through my experience over the last 30 years of how data's been used and abused on tunneling contracts. We're not going to sell you any systems, but it is Black Friday tomorrow, so don't forget the family deal and put your orders in. Okay. Right, let's just go to the next slide. Come on, slide. There. So what are we going to talk about? First of all, obviously, why is data important? Sounds silly, really, but it's always good to sort of address that. And also, what data are we talking about, and when is it provided? Data is also part of processes. So what processes are we trying to look at, trying to improve, and how can it go wrong, and why? And what connections are needed. Often things need to connect to talk to each other. What do we need there? And then I'm going to go through a history of data, particularly the different types of contracts that we've been involved in, and how data is managed within that sort of contract environment. So first of all, to set the scene, I normally do this sort of word map. So there's two or three main areas that we focus on with regards to data. One is risk management, and I think I can encapsulate risk management in sort of an observational engineering. It's recognizing there's uncertainty within construction contracts, particularly with regard to the ground, and managing that by using data effectively. And then, of course, that's the sort of design side of things. Then there's also the productivity, making sure you've got data so you can identify where time is going, where money's going, and where the quality is at the moment, and where it can be improved. And then within this environment of data, we've got all these buzzwords now: digital twin, data mining, Industry 4, all these sort of things. But really, it focuses on these purple items here, which is really about, what opportunity is there to automate? How can I get quality data quickly to the people who need it? And those people really need to be spending their time on doing things like analytics, planning, and forecasting, rather than cutting and pasting and producing paper reports, which is often what is done. And the data here covers all sorts of different types of information on jobs. So often we have systems that focus on just one or two areas of this, but really we need a system, combined systems that focus on all that, from instrumentation to production, to machines, to resources, to records, safety, ground risk, everything in one place. And we're talking about tunnels today, but systems, really can bridge from tunnels to bridges to industrial to environmental to whatever. So this is really where we are as a company and where we sit in terms of addressing data on projects. And in terms of the when, this is the project data cycle that we often consider, and it goes into sort of 5 main steps. One is the collection of the influences on construction, on the tunnel. So this is the boreholes, the risks, the hazards, the constraints that may be there, and all those feed into the next one, which is design stage, which the output of the design stage is a set of predictions. It's how deep is my pile going to be? How quickly is my tunnel going to be progressed? How much settlement will I get? These are all predictions that need to be brought into the sort of the data set that people are using. And then we go into production through a tender process, and we're monitoring not just the progress of construction, but also the records and the quality and everything else that is done during the process, and also, of course, the safety. And then these 2 elements, the design and also production, are part of the monitoring. Often we think of monitoring, just monitoring against some design, so protecting the environment or whatever, but the monitoring is there to monitor against production. We've made some assumptions. Are they right? Is there a better way of doing things? Can we identify deviations from our predictions? And then so often what happens is the end of construction, that all stops. The system you had in place is then sort of wrapped up, mothballed, put somewhere, generally forgotten about. And then a new system is there to manage the performance of the asset. Well, it's ridiculous that the system used to build the job is not then used to monitor the performance, because you need to go back to the system, when the asset when it's constructed, to understand any way in which the asset might not be performing in the future. And if you do this cycle, then businesses really can use that data as the input to the next stage. And by doing that, each one of these little cycles can reduce in risk, and over time, the risk in business, either as a contractor or as a client, will go down, because you're using your data and keeping it alive. And this is the information engineering we referred to in that first word map. Now, one of the big issues with data is we have so many different formats of information to be able to combine. And I'm currently involved with in a conversation with Paul Burton about being able to communicate information from construction projects in consistent formats so that people can use it effectively. And connections, we have so many. Here's just a handful of tools that are used on construction projects, particularly tunnel projects frequently. How do they communicate together at the moment? And this is really the sort of the nirvana of engineering at the moment, how to get all these different things to communicate, connect, and talk to each other machine to machine, rather than have to do a lot of manual processing to do so. And this is very much underlying what we've been trying to do as a company. So I wanted to just throw these things out. I'm not going to talk in too many details. I'll leave these hanging, and I think we'll come back to them at the end. Here's some examples from my experience of how it can go wrong. So the first one, in an ongoing contract, when offered the full information on a tunnel that was driven 25 years earlier and directly below the current alignment, a contractor did not want to see the data. Why would that be? Okay, that's number one. Secondly, a contractor bought a machine from a supplier, but did not let the supplier see the data for the machine. Why? A main contractor engaged a subcontractor to do the drill and blast, but did not require the subcontractor to share the drill jumbo data in his contract, which the subcontractor then later refused to do. Why would he do that? A client, so this is all contractors, now this is client. A client collected INSAR for a project to identify background movements, but did not share this data with the contractor, either at tender or during the contract. And another one for a client did not provide, and this seldom happens, a client did not provide the AGS digital data to contractors at tender, but only the factual paper reports. So if the contractor is not using the AGS data, then who is? So I'll leave those hanging, and maybe we can come back to those points of discussion after we talk about the rest of the topic. So what are the sort of the key or the common reasons why things go wrong? Well, what is referred to quite frequently is siloed behavior. People working on their particular bit of the work without reference to the rest of it. So you might have geotechnics working on geotechnics. You might have a survey working purely on a survey. You might have a designer working on design. You might have production working on production, but nothing, no talking, no sharing from one to the other, or sharing is done in a rather clunky and non-collaborative way. And part of this is a sort of a feeling that data is power, data ownership rather than data sharing. And what we see often, and it refers back to the previous slide, is we see often data being sort of weaponized in contracts, because people say, oh, I need to keep my powder dry. That information may be useful when I'm doing my cost recovery at the end of a project, or I need to keep that in my, private to me, because I know if something goes wrong, I need to use that. And we've had some experience of this in fact, Bill and I on a contract many years ago. But who owns the data? And I'm going to throw this out as well. Well, actually, looking at the contracts that I've seen, ultimately the owner owns all the data. It's part of the intellectual property of the project, and the contracts are clear about intellectual property. None of the data is pre-existing prior to the project being, or the contract being signed. Therefore, it must be the ownership of the client. The contractor has the right to use the data. So we can talk about that later as well. There's probably some legal people on the call who might be able to look at the actual details behind this. So as a company, what do we try to do? Well, we try to create a platform that does these things, which connects information together and is configurable, allows people to use data and connect the data they need. So the reason it's called MissionOS, because it is an operating system. But rather than sell the project, I wanted to go through a history of how we developed and got to where we are. So the first kind of contract that I was involved with was a good old-fashioned engineer's design using the ICE conditions of contract. It's called design bid build in America. And this was a deep tunnel contract in Hong Kong called a strategic sewage disposal scheme. So Bill and I were both on this job when it went quite badly wrong, because we had lots and lots of water. This was the tunnel, this is 1999, and this was just one outflow from a probe hole, about 1,000 litres per minute, about 10 bar. Now, characteristic of these jobs is that there's two sets of records. There's the client's records and there's the contractor's records, and there's man marking from both sides. So the focus the whole time is on which of these records is right, and what to do if there are differences in the record. Do you throw all the records out, or what? It's largely a waste of time, really, having this thing, because the lawyers have spent a lot of time looking at the data and identifying what is the data. Ultimately, on this project, this is when I set up the first construction data management system, because I knew the contract was going to end up in arbitration. And we set in place a system that managed every 15 minutes of time, and it was completely auditable. So if in the shift report records it said that you had probing done or cutter changes done, then there was a record in the system for that. Now, the arbitrator on this contract identified the data records as being key to the outcome of the job. One side provided all the data, the other side cherry-picked the data that supported a particular case. And as a result, the result of the arbitration, if you like it to a tennis score, was 6-love, 6-love, 6-1. And this was an impossibility arbitration for a 26-kilometre tunnel project. Now, the government decided that they liked having the data in this sort of quality, so they decided to force this standard of data into the contracts. So they actually wrote it into the construction contracts from then onwards. This is 2005 in Hong Kong. So a lot of contracts then in Hong Kong went towards design and build. And here's a contract that we did. In fact, Melbourne Metro and Liantang are two contracts with Bui that we did recently. And here in Hong Kong, this is a very interesting tunnel project with a lot of uncertainty. Okay, so you can see on the right-hand side, we've got, also left-hand side, we've got large span, low cover, large diameter machine going in. There's a second tunnel to be excavated between there and that big tie-back wall. And we've also got we've got a large hard rock TBM. We've also got very poor ground conditions. And the nice thing about this design and build approach was that whilst the system to manage the data was required by the client, actually, after a period of time, the contractors realized that they could use this system to support the management of uncertainty. So in this case, they used the system to log a lot of this information that was supporting alternative designs to the construction of this portal. And in fact, they saved about 7 weeks of program by being able to remove a lot of the steel supports by using the data effectively. What you're looking at on the right-hand side here is the lateral movements of the portal as it moves away due to the construction of the adits. Now, in this case, the client specified a system, and on the Melbourne job, it was what's called a MIM system. So it was just the instrumentation plus a certain amount of progress of the works. In Hong Kong, the TDMS system, that's Tunnel Data Management System. And that actually has progress of the works plus the instrumentation plus the construction records in it. Now, this little thing over here is essentially some contractors feel that a system put into their specification by the client is a noose by which to hang themselves. So there is a reluctance for them to actually conform to provide the records that are requested. However, in the modern systems, we can provide private areas. And in this case, on this project here, because the alternative design was the contractors, there was a private area where his information could be used and kept private to himself for his own IP. Now, after about 2005, we entered into a period of alliances, particularly in Australia. They also did some alliances on particularly difficult jobs in Hong Kong. And now we've now gone full circle, and now alliances are quite common and certainly are being promoted in Australia again. In our alliances, there's one party. There's a target cost. There's one party. Even if you are employed by the client or by the contractor or by the designer, you wear the hat of the alliance. And the great thing about this is that there's one set of records and there is one system, and it encompasses all the data. And everything is done on the job for the general project benefit. And I have to say that in my experience from a technical perspective, alliances have been the best technical solution to delivery of projects. The reason they're not used so much these days is because sometimes clients feel that they're paying too much. Sometimes, there's the pain share, gain share, which is unpalatable in certain cases. But from a technical perspective, these are very good. And what we have found is that an engagement with regard to the use of systems in this is excellent. There was a partnering approach to delivery of data, the use of data on the job, and everybody is involved. So that gets a big thumbs up from me. No noose by which to hang themselves. Claims are dealt with by the alliance. They apply cash flow, they identify cash flow as required to reach the target cost if they can. So the next one is what I call PPP, a monopoly. I'll deal with a monopoly first because this is where this started for us. In Hong Kong, there used to be two rail suppliers, the MTR and the KCR. They then merged into one body, which was not a government body. It was actually, I own shares in the MTR myself. So it's a semi-private body, but it had a monopoly on rail supply in Hong Kong. So as a result, the government required the existence of independent bodies to audit the projects that they were doing in 2011. One was the Regional Express Line, the second was the Sha-Tin Central Link. And we were engaged as the auditing body, it was called IMC, or the Independent Monitoring Consultant, to really look at the technical delivery of the contracts and make sure they were delivered without causing undue damage to the surroundings. And the advantage of this was that they managed to secure up to a 0.1% reduction in their project premium. This is 0.1% of the full project value, just by having this system and role in place. So the insurers really looked kindly on having this sort of project-wide initiative in place. Now, this was actually a client's incentive, and unfortunately was not really pushed out too far certainly to the designers in this. So it's very much run by the client for the client's own internal checking purposes. And I think in future, it would be good if it was more widely pushed out to the contractors, some contractors, so more wider use. And I put this in the same bracket as PPP because the PPP now, and I think this is quite common now in Australia and also in the USA, public-private partnership. Really, you've got one party, and it's there's engagement in the project owning party, the financing and everything else in the delivery of the project. So having an independent consultant body to do this thing fits in the same kind of environment. Now, leading on from this, a little story. We went to see Singapore Power in Singapore, and we gave a presentation of a system. And what I didn't know was that the phase one that Singapore Power did actually went quite badly because they had some undue settlement, which shut the job down for quite a while. It's the first time I ever gave a presentation, and there was a lawyer in the room, and really shining lights into my eyes. And the director of this project actually said to me at the time, you know, it's interesting. People assume that because I'm a director, that I'm no longer an engineer. And this person was actually a geotech engineer. He said, I want to be able to see what's happening and make my own mind up. I don't want to just have to read what I'm being told. So when we showed him the system, he said, that's what I want. That's what I want to see. So the tender was put out, and we were engaged to provide this. Now, it was quite late on this job. So tenders were already out to 6 contractors to do the 30 or 15 total kilometers of tunneling. So they opened up a conversation with the contractors during tender and said, okay, we want to partner to improve the way information is being managed on this project. And to do that, we want you to contribute to the cost of a system and sign up to a charter for information, which says we want to minimize the amount of paper we produce. We want to optimize the transfer of data. We want to release people from Excel. We want people building tunnel, not building libraries. Okay. And they, of course, they all agreed to do this, and it was delivered. And after a little bit of initial reluctance, because obviously a contractor is not used to opening up and being this transparent with data, after a bit of reluctance, people realized that there were significant benefits, particularly in that their normal processes were reduced significantly on the project. And ultimately, the data set that was produced was extremely valuable and allowed, I think, pretty much all of the contracts to be delivered pretty much on time and within budget. And having all the data in one place enabled us to develop, dashboards. That's, dashboards is the word of the day at the moment. These were dashboards from 2012, 2013, being able to combine TBM data, design prediction data with the instrumentation data, even looking at the contours of the face pressure on the machines at any particular time. And we had 15 machines on one platform, all recording and visible. And not all people could see everything, of course. Individual contractors could only see their own part, but the client could see everything. And it was a standard, it was a common data environment in which information was being presented. Now, in the UK, there is wide adoption of the NEC contract now, and a sort of an alternative to the partnering or alliancing is a sort of an early contractor involvement kind of tendering. This is a 2-stage tender where there was initial appointment of contracting groups, and then a period whereby the contractor and the client work towards refining a target cost of the system. Now, we've talked with a number of people about this, and on some that we've done, the systems have been left till the last minute. So left until the target cost has been identified and cemented, and then they come in and say, right, we'll have a system. So actually the discussions at the moment are that systems on projects should be considered as part of the ECI phase. They should be considered as a value engineering exercise, and they are there to identify ways to promote risk reduction on projects, to be able to look at automation, cost reduction, do jobs with smaller, more focused teams. And what's happening now is they're starting to be considered as a joint client and contractor innovation. Now, this means that the systems start to get discussed and implemented before the contracts are finally awarded. And that's in play now on a couple of projects in the UK. Now, the last sort of method of contracting really is that the client actually takes the data out and decides, I'm going to define how the data is going to be run. I'm going to set the standard. So this is where the client says, right, I'll define a system. I will define my common data environment. I will define the way in which contractors and suppliers provide data into this platform and interface with it. And this will be used to essentially manage all the information flow on the project. And this is what's been done on the DTSS2 project and the Changi Tunnels project in Singapore. Now, this was attempted early on, I think, first phase in London with Crossrail, with a USIM system, which was actually mostly focused on construction progress and instrumentation. That was quite early. And in fact, the mixed delivery on that one, I would say. And I think one of the ways in which the limiting things for that one was that I think the client specified in some great detail exactly how the system should work. And in fact, on these client-driven CDs we've done, they've actually more decided on an end specification, what it should do rather than how it should do it, which means that we get to decide on the means and methods of provision of the data as long as it does the things that the client is looking for. So on this project, on DTSS2 that you're seeing here, they have a boardroom with a control interface to the whole of the project. So this is 100 kilometers of tunneling, 50 kilometers of larger diameter with 5 TBM contractors with about 4 TBMs on each project. So there's 20 TBMs on each system, recording to the system, to the stems, as they call it, every 5 seconds. That's a world record. We've also got 4 vertical shaft sinking machines linked to the system, and we've got dozens and dozens of pipe jacks also, with totaling about 50 kilometers, driven from about 300 shafts. There's a lot of people on this system. There's over 900 users. We're currently at 35,000 instruments. We've got more than 300 CCTVs linked into the same platform with biometrics. And one of the very interesting things here is that all of the reporting now is done through the platform. So on this one, it's up to about 75,000 pages of PDF per month are being generated on the project. And a lot of that is highly automated. So what can we do when we get it right? Well, one thing that clearly happens, and I think everybody on the projects for DTSS2 or in London now, we found that the communication is hugely improved. We would say, compared to previous methods of managing this sort of data, the processing and the communication, providing reports and updating things, probably 80% reduction in time taken and a 500% improvement in the response time. So we can also de-risk projects. Being able to get to all the data means that you can see and you can forecast and you can predict much better. The claims process is simplified because we agree the data at the time. There is no post-event interpretation, let's say, of the data or the factual data. It's there and it's agreed at the time. And the claims process is just about agreeing the method. Clearly better forecasting. The more information you can get together in one place allows people to forecast more reliably. And if the data is in a format that's easy to access, then engineers can do a lot of great things and they can focus the time on being able to do that. And that's the greater capability element we've got at the bottom. But also there's this realizing the opportunity. There is always uncertainty on construction job, particularly in tunneling projects. And giving the engineers the opportunity to manage that uncertainty, look at ways of alternative designs using observational engineering, being able to forecast, being able to identify new means and methods, I think is really, really important. And data is the key to unlocking that opportunity. And going back to HATs, one of the nice things that the client appreciated really about the phase one was that the data set that we provided to them was in a data warehouse, which was very, very easy to use. We turned it into cycle statistics, and the cycle was every meter, every blast, every whatever, and they could use that data to come up with statistical relationships for data that could be described and can be used for forecasting. This is grad injection, this is Q values in materials, and it could be used for forecasting on the future project. And by using this data, actually the provisional quantities they came for grout and for length of drill hole were arrived at within 5%. So actually a very accurate prediction. And this is 26 kilometers of borehole, if you imagine, horizontal borehole along alignment that can be used to forecast rather than just relying on a few vertical boreholes for a tunnel project. And then in Melbourne, we have spent a lot of time automating the reporting cycle. So they're actually producing 40,000 pages per month of report. This is done by one person and none of it is printed. So this is a huge change from before, where you may have had 5 people whose job it was just to generate the paper that was required to be submitted on tunnel projects. And several trees every month were chopped down to produce what I would call Kentilage in people's offices, because a lot of these reports were just sitting there and very rarely were read. And the nice thing about having this data in one place is we can reduce meeting time. We can do pre-preparation. We can give people reports on the fly. They can look at them when they come into the office. And we can also create digital twins so that people can have a combined understanding of what's happening in the job. This is the HS2 in London. And we've got a combination of all the instrumentation. We do the progress monitoring of the construction works in the same system. We have all the instrumentation in here. We even have the LiDAR data all in one environment. So everybody's got the same understanding of the works. Every day on this job, they have to do a shift review group meeting on all of their sites where active works are going on. And that happens anywhere between 8 o'clock and 9 o'clock in the morning. And the system actually generates all of the reports to them on the fly, well, in advance, so they can review them. And then the system also works them through the process of doing the minutes of the meeting and approve, and then it will actually sign off the meetings for them through an email, which they will click on and then close it. Now, what I want to do is just to finish off, is just to show you an example of how data really can improve understanding on our project from a geotechnical point of view. So I'm just going to go over to a browser. Okay, I've just shared a different screen. Screen. Okay, hopefully you can see the screen. This is a view into our MissionOS platform, and this is actually one of the world's first variable density machines. And this is coming through karstic limestone. And you can see here is the contractor's long section showing some areas of karst, whatever. And the tunnel alignment is just down here at the bottom of this grouted block here. Now, what we can do is, if we just select the area in here, what we do now is, with our digital twins, we don't use CAD. So a lot of BIM or digital twins now is focused on CAD systems. We actually use a kind of a gaming rendering, online gaming rendering. So if anybody's seen Minecraft, the same kind of technology is used behind that, which means that you can do very, very fast rendering of three-dimensional objects. So when you talk about BIM, this building information modeling, we actually focus on the information bit of it. Okay, so the information is held within the system, and the 3D bit of it is just generated on the fly. So what you can see here is everything that was on that GIS is now created in 3D. Now you're looking at that section now where we've got the karstic limestone. Here's the limestone, here's the cover, and here's the karst. Now we can click on this wall here, and I can show you RQD. This is geostatistics. So this data here is created using geostatistical modeling. So we can model RQD, we can model also, if I go back to this, the probability of encountering voids. Okay, so what we can do is we can click on this tunnel, and I can now bring in the TBM parameters. And I'm going to plot the average face pressure. It sounds like a cookery program. No, okay, so what it'll do is it'll plot the TBM parameters below the base of here. Wait for it. There we go. Okay, so let me just get rid of the tunnel. Move this down here. Okay, what we can see now is that here's the face pressure. So we're running at about 3 bar all the way through here. Boom, blue, lose it all. Okay. Luckily, this was the trial section, so nothing happened. Okay, but here is a blue section where they lost the face pressure, changed the mode over about 15 rings until they came into EPB mode, and then they carry on okay. But look at the statistical or geostatistical prediction for the ground conditions actually gives a pretty good estimation for where the ground or the likelihood of there being karst occurred. Okay, so by doing these methods, building these methods in, it's really quite good at being able to give you advanced prediction of what may be there. And the good thing about the geostatistical methods, and there are other methods that are used, is that they're driven by the data. So any new boreholes that can come up, they can give you a new interpretation. So imagine, and I've always said this, driving a tunnel these days is like driving a car with the headlights off. Okay, so if you're in a tunnel, and I'll put the tunnel back on, this is what you could see. Okay, so why do we not actually have this information in the TBM so that the TBM driver can see what's coming and address it? Had he changed his mode here, he would not have had this issue. Okay, now I could show you a lot of things in here in terms of obviously we also do things like tracking even the segment yard and the segment construction and whatever. But I'll leave it there, and hopefully we've got some questions. Thank you very much.
Yeah, thanks, Angus. I forgot to mention at the start that there's a little thing at the bottom of your Zoom meeting where you can tap in a question. So while you get your head around that, I'm sure you've got some questions for him. I'd like to go back to the questions you asked of yourself, Angus, if we could, while we wait for
let's find those questions. The ones at the beginning.
Yeah.
These ones.
Yeah.
Yeah.
So, well, I'm sure you've got answers to these. These are all real-world examples, right?
Yeah.
So I think it's only me and you talking.
I'll give you an opinion. I'll give you an opinion. The first one, in a claims environment, you don't want to, certainly after the contract, you don't want to then discover information that would potentially, or you feel might potentially scupper your ability to claim on a project. So it seems crazy that somebody who's doing a job might not want to see information that comes to light. But if it impacts commercially on the job, there may be a line of thought to say, no, I don't want to know. I was given certain information, and I'm going to go to the client with a claim on the basis that he did not give it to me.
Yeah, I think that deals with the first three, doesn't it, really? Possibly not the third one, actually. But what's even more fascinating is why a client would go out of their way to not help a contractor understand the job in the fullest extent.
Exactly. I mean, the last one there, the age of digital data. I mean, before I came out to Asia, I was involved in High Speed 1, and I was actually responsible with a small team of managing 5 big ground investigation contracts. And we put together a geotechnical database there that was provided, the database was provided to the contractor during the tender period. They could log into the database. They had to, it wasn't on the web in those days, it was 1994. But they could come in, log in, and had access to all the digital data and could download anything they wanted to view. I've never seen that done again. In fact, whenever I try and get the AGS digital data for a contractor from people, it's like, no one's asked for this before. It seems quite quite unusual. Normally, it's in the United States, it's all down to paper records. None of the digital stuff is provided. A lot of wasted time.
Yeah, absolutely. Look, there's a question here from Alap. I'm not sure if I'm getting that right, but how well does the data capturing of tunnel works for facilities management after the as-built stage? How well does the data capturing of tunnels, I guess, for facility management at the as-built stage? And so how do you turn all this into as-built information? Yeah.
Okay, so in terms of as-built, what is the as-built that you have to provide to the client? So ultimately, nowadays, the client wants the BIM. Okay, that the BIM is the. It used to be that it was drawings, and I remember a time when a contractor said to me, "Oh, Angus, we're going to employ a CAD draftsman for 3 months to create the as-built drawings for all the monitoring on a job." And I said to him, "Oh, I'll tell you what, you pay me half of what you're paying him, and we'll do it." So we just wrote a script to create the drawings directly from the database. Took about a day and a half, and provided these drawings, and we've got 1.5 months of the CAD person's time to do the same thing. So the data is there; it's already in databases. So if we can move away from saying it must be on a drawing, you can save a lot of time. But nowadays, obviously, it's going to go into BIM. So we need to make sure that the connections are there between all these other databases of data information that can go back to the BIM, and then the BIM will be provided to the client.
Yeah, there's a related question. Thanks for that question, Ala. Which is, you said earlier on about value engineering, and the trouble often with these big jobs is by the time you've got ready to go, there isn't a lot of time left to actually, unless you've pre-planned a series of scenarios, which is in classic observational, leave something out. But otherwise, there isn't a lot of time. But the other thing that strikes me, certainly if you're in any city of the ones that you mentioned, is the value you get from sharing the information for the next job, which is a key tenet of any GBR. And even to the extent of a city like Sydney, you could make a reasonable case now. You don't really need GBRs if you had a really good handle on, what you would expect, depending on how you defined it, of course. But so I guess it's two parts to that. Then one is how do you build in enough time to capture the value engineering you might get from improved data, and then how do you learn from each of these experiences and the vast quantities of data that you generate to actually improve things next time?
So the first one is value engineering. So the newer forms of contract, the NEC two-stage process, really has the value engineering built into that second stage. So this early contractor involvement, where everybody sits down and looks to value engineer the job and arrive at a better target cost. And that's great, because really everyone's got their hat off and they're looking to identify. And in fact, in that stage, there could be 2 contractor teams working with the client to identify the best product, ultimate proposal, and the client will actually reimburse the contractor they don't want to go with for the cost of the time that they spent on developing their potential bid. So that in that case, there is a lot of time to develop these things. In other forms of contract, in alliance contracts, I'll go to that first. Alliance contracts, the value engineering is done as you go, because at every stage you are sitting down collaboratively and looking at opportunities to optimize the project. So the contracts where I have actually been engaged in to do observational engineering most often were on alliance contracts, where they're looking to, okay, have we been overly conservative in design? Have we done some more boreholes? Do we have more information? At every stage, every month, can we look at opportunities to do things faster, better, quicker, safer? So those work really, really well. The problem is where you end up with this sort of design, bid, build, or the old-fashioned contracts, or design and construct, where essentially you have limited information at tender, you have limited time at tender to do things, then bang, your program is running. And nothing is ever built into the program to be able to do this sort of value engineering of the job. The client's immediately saying, I need delivery of this, 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 and this. TBM jobs, you've got a lead-in time, obviously from the TBM being provided. However, the value engineering often might be different TBM. So you can't suddenly decide 3 months into the TBM order, I want to change it, but you can add a few things, but you can't wholesale change the machine. So yeah, I agree with you. I think on some of those, the conventional design and construct or build only contracts, it is difficult to implement.
ECI is a great way. We've had a couple of goes at ECIs here. I don't think they've necessarily worked to the extent that we would have liked. But in principle, I think they've got a lot of offer. And it leads to another question here from an anonymous attendee who says, do you consider alliance contracts to be most suited to tunneling projects, Angus?
Okay. From a technical perspective, alliance projects work very, very well. I think in terms of, from my experience of all the contracts I've done, they are good. An alliance was, 2 alliances were done in Hong Kong, and they were done specifically for the most difficult bits of work to be done, because they would seem to be a much better way for the client to engage with a contractor to get what they wanted. And also obviously to remove the pressure of contractor cash flow from it.
The control of the scope. Would you say, in that sense, it keeps the client closer to the scope of the design and managing the risks that way?
I mean, from my perspective, one of the biggest risks in a construction contract is cash flow for the contractor, and often the contractor is being asked to fund the project with the sort of the assumption or the expectation that at some stage in the future he'll get paid money for doing this work. The alliance contract, particularly the target cost, where it focuses on cash flow on a month-by-month basis, making sure that the contractor has enough money in the job to deal with the problems which are currently facing him. So it's really good at dealing with uncertainty and events that happen on jobs. I mean, events happen, and you need to be able, particularly in these very, very tough jobs, you need to be able to react in the proper way. So that's why I think alliances work well on those kind of tough tunnel projects. They're not so great when, for instance, you get the gain share, pain share approach to it, when the scope changes. Yeah. So if the scope changes, then the client may go and say, oh, scope change, gain share, pain share, whereas the contractor says, hang on, this is just an increased scope. So there has been some discussion there, and I think I've heard from some clients that they feel maybe they're not getting value for money, and they can't sort of put the pressure on the contractor.
That perception's out there for sure, and the alliance model we use here, that limb 1, if that goes up, then everything else goes up on top of it. So there's another question here. Says, what can be done to deal with contractors who don't share all the data? So what can you do if somebody doesn't want to share the data? So this might be.
Okay. I mean, I've been on contracts where there are strong clients, and I've been on contracts where there are not strong clients. You just have to be a strong client. You have a contract. It says what it says, and you have to enforce it, and you do what you have to enforce it. As I say, if you've written it into your contract that says the contractor has to do this stuff and they are refusing, you have to do what you have to do as a client.
Yeah.
Within the contract. and otherwise, you won't get what you want. So I've seen some very strong clients who, will stop the job.
Yeah, it's related to the appetite for risk and the understanding of risk, I guess, information. If you wanted to disarm your data and didn't weaponize it on the basis that you're trying to incentivize a good outcome, or you should be, rather than just trying to stiff the other guy.
Exactly, and this is why as I said, the success of that partnering approach on the Singapore power jobs, for instance, where everybody had a stake in the game. They had signed up to the charter and they were paying for the system. So, it was at executive level that they had engaged on it and they'd agreed. So there was no discussion about, well, whether we want to or what. This is what they had decided to do. So that was very encouraging. And whilst it was a little bit uncomfortable for me initially, after a while, it was like, no, why don't we do this every job? So, I think it's a case of getting over that hump of, I shouldn't share, I should keep this, I shouldn't give it out. No, it's much better just to sort of open things up and say, okay, we've got to deal with issues and make sure that we're not wasting time on cherry picking data and having that sort of argument about the data rather than the solution.
There was one other story you told me about the measured mile. So you were a lot closer to SSDS than I was, but it was an example where it's probably not that common for people to be aware of, but maybe you could take us through that measured mile concept. It's part of a sort of dispute avoidance process.
So once you've got really, really good data and it's agreed data on a project, your discussions. I was actually a contracts engineer for a year, wrapping up claims on replacements contract whilst after the initial contractor had been removed from the job. So this was actually scrutinized by lawyers on both sides. And once we agreed the data was fact. So there was no time spent on saying, I've got this bit of information says this and whatever. So you create a data set. And once you've got that, you then just agree on the method by which you're going to evaluate a claim. Now, a method that was around at the time, probably still is by identifying a measured mile. A measured mile means, okay, let's say the engineer has stepped into the job and started instructing stuff, let's say probe holes. You say, okay, that's caused me to be slower. Therefore, I'm going to claim that I have rights to get an extension of time or whatever. So what you do is you find a similar section of tunnel that you can agree is effectively the same. One where the client has been instructing you and the other where the client has not been instructing you. And you look at the statistics, you say, is there impact? And if there is an impact, then you can agree that, okay, over above certain 10% or whatever, in terms of time taken, you will pay for extension of time. But if there isn't, then you don't. And in fact, on a couple of occasions, we found out that through the instruction, the job actually went quicker. So, no claim. So it was a good way of doing it. It removed that argument that you always have over the data. I've got this data, you've got that data, we don't agree on the data. So agree the data and then work on the method.
Very good. Hey, I think the questions have dried up, so I think we'll draw a line under it and let you get on with your day, Angus. Thanks very much for
thank you for the time.
Yeah, no, I'm sure everybody enjoyed it. Well, look, it just remains for me to wish everybody happy holidays. It's been and have a good break after a long and exhausting year. Hopefully things will get back to some sort of semblance of normality in 2023. But thanks for coming along, everybody, and thanks for all the questions and for your attention. So
yeah,
there we go.
Hope to get to New Zealand soon.